Question number 37. The difference between the apparent frequency of a source of sound as perceived by a stationary observer during its approach and recession is 2% of the actual frequency of the source. The speed of the sound is 300 meters per second. The speed of the source is, alternatives are 12 meters, 6 meters per second and 1.5 meter per second and 3 meters per second. Now, in this problem, a observer is here and a source is approaching and then it is also receding. So it is approaching and then receding. So what is the formula? So observer here is at rest and source is first coming toward the observer, and the second case is source is moving away from the observer. So when the source is coming toward the observer, the apparent change in frequency is V minus Vs when the source is coming toward the observer. When it is receding, the apparent change in frequency is given by V by V plus Vs into nu. So what is the difference between these two frequencies? We can now take the difference between the two frequencies is nu dash minus nu double dash is V by V minus Vs divided by V minus V plus Vs into nu. So taking common, we can say it is a 2V Vs by V square minus Vs square into nu is a relation. Now, since velocity of the source is very less when compared to V, neglecting Vs square here, dropping here, so we can say nu dash minus nu double dash, the difference in frequency is going to be 2V Vs by V square into nu. So V will get cancelled, so it is 2 Vs by V into nu, but this is given as 2% of sound, that is nu minus nu dash is given as 2% of sound. So 2% of frequency is 0.02 nu. Now we can calculate nu can be removed, so we want to calculate velocity of the source, so it's going to be 0.02 V by 2. So 0.02 by 2 into V is given as a 300, so 0.02 by 2 is 0.01 into 300. 0.0 into 300 is 3 meters per second. The correct choice is D.